Welcome back, everyone. Ready to jump into Module 3.
Absolutely, let's dive in.
It looks like we're tackling backup clients this time around. Should be interesting.
It really should be. I think this module ties together a lot of what we've already covered. We spent a good amount of time talking about storage and networking.
Right. Laying the groundwork.
Now we're going to see how those concepts apply to actually protecting data in a variety of different systems.
So we're talking about everything from, like, those simple file systems all the way up to, those big, complex databases. Oracle, SharePoint, those kinds of things.
Exactly. And along the way, I think we'll uncover some of those surprises, especially when we get to virtualization. That's where things get really fun.
Okay, so first things first, let's start with the basics. When we talk about a backup client, what are we actually talking about? It sounds a little bit, I don't know, it sounds a little bit like a sad little computer begging for data scraps.
Huh. Not quite. Think of the backup client as the source. It's the host, the actual machine where the data lives. So that could be anything, really, like a laptop or a server, even a mainframe.
Okay.
And it's not just about accessing the files themselves.
Right.
The backup client also gives us a way to interact with the applications on that host. And that's where things get really interesting.
Because applications don't just store data willy-nilly.
Yep.
They have structure, they have logic.
Exactly. That's why consistency is so important when we talk about backups. Imagine you're trying to restore a database from files that were backed up, at different times. It'd be a mess, right?
Yeah.
Completely unusable. We need to capture a snapshot of the application's data that actually makes sense together.
Gotcha. So we're not just copying files randomly. We need a strategy.
Absolutely. And that's where cold backups and hot backups come into play.
Okay, I've heard those terms before, but remind me.
Sure. So cold backups are taken when the application is offline. It's like taking a time machine back to that specific moment. Everything's frozen, everything's consistent.
Got it.
Hot backups, on the other hand, happen while the application is still running. It's like trying to take a picture of a moving target. We need some special techniques to make sure we get a clean copy.
And these different backup methods, I'm guessing they apply to both file systems and the databases.
Yes. For file systems, we'll be looking at those open file agents. That's what allows us to back up files even when they're being used.
Okay.
And with databases, we'll dive into the world of database backup agents and transaction logs.
Oh boy, transaction logs. I remember those from, like, my college database management classes.
Yes. Those detailed records of every change made to the database, they can get pretty complex, but they're crucial for point-in-time recovery.
Right. Okay, so those are important. But I'm guessing different databases have their own quirks. Like, are we dealing with a one-size-fits-all situation here?
No, not at all. Each system has its own terminology and its own methods for backing up that data.
Of course.
We're going to dive deep into some of the heavy hitters like Oracle and Microsoft SQL,
Oh, fun.
even Exchange and SharePoint.
I'm already taking notes.
Get ready for a whirlwind of table spaces, data files, redo logs. It's like a whole new language.
All right, don't overwhelm me just yet.
Okay.
Before we go full-on database geek here,
Sure.
let's talk about something a little closer to home. My laptop.
All right.
I know there's this thing, VSS, that has something to do with backups. I have no idea what it actually does.
VSS, that's Microsoft's volume shadow copy service.
Yeah.
It's actually pretty clever. It allows us to create these consistent copies of your data even when files are open and applications are running.
So even if I'm in the middle of editing a file,
Yeah.
VSS can grab a clean copy without messing things up.
Exactly. It's like hitting that pause button on your whole system and taking a snapshot.
Okay, that makes a lot more sense. So is VSS the magic behind all our backups? Or is this just for individual computers? What about, those giant file servers packed with terabytes of data?
For that, we have NDMP. That's the Network Data Management Protocol.
Oh, NEMP.
Think of it as a special language that backup applications can use to talk directly to those NAS devices.
Right, those network-attached storage boxes we talked about in the storage module.
Yeah.
The Fort Knox of data.
Exactly.
So NDMP helps us protect all that data without, bringing the network to a screeching halt.
Yep. And we'll explore the different types of NDMP backups.
Okay.
And why they're so important for large-scale data protection.
Gotcha. I'm already seeing how everything we've learned is kind of coming together.
Yeah.
Like storage, networking, and now these specialized backup techniques.
It's like we're building a data protection fortress, brick by brick.
Exactly. And speaking of building blocks, let's move on to another big one.
Oh.
Virtualization. Now we have to back up virtual machines too, right?
Yeah.
But, Isn't that just like backing up a regular computer?
Well,
It's just a file, right?
it's not quite that simple.
Right.
Virtualization throws some unique curveballs into the mix. Remember when we talked about those core characteristics of virtual infrastructures? Partitioning, encapsulation, isolation.
Right.
Those all play a role in how we approach backups in a virtualized world.
Now you've got me intrigued. What makes backing up virtual machines so different?
Well, think about it this way. With virtualization, we can treat entire servers as files.
Okay.
And that opens up a whole world of possibilities when it comes to backup and recovery.
So it's like having superpowers, right?
Yeah.
We can manipulate whole systems like they're just simple files.
Haha, in a way. We're going to look at how VMFS, the virtual machine file system, lets us manage those virtual machine files across multiple physical servers. And of course, we'll compare that traditional guest backup approach where you treat the VM like a regular client with those more advanced VMware image backups. Those leverage the power of VADP.
VADP. That's a mouthful.
It stands for vStorage APIs for data protection. It's powerful stuff.
It sounds powerful.
VADP allows backup applications to talk directly to the virtualization platform, which gives us more granular control and efficiency.
Gotcha. All right, so we've covered file systems, databases, and now virtualization. It's clear that backing up data is way more than just copying files to an external drive.
Definitely more to it than that.
But I do have one more question that's been bugging me. We've talked a lot about backing up the data, but what about getting it BK? Restoring it?
Yes. The flip side of the coin. That's just as important as backing it up in the first place. We'll delve into the world of data restoration in the next part.
Sounds good. I'm ready when you are.
Welcome back, ready to dig deeper into Module 3.
Definitely. Last time, we sort of laid the foundation, right? Talking about what those backup clients are and, the importance of data consistency across all those different systems.
Exactly. And this time, I thought we could roll up our sleeves and really get into the nitty-gritty of databases.
Uh-oh. To be honest, databases always make me a little nervous.
Really?
Yeah, they always seem so much more complex than, like just regular files.
I can see that.
Are we going to have to, write SQL queries to back up data?
Haha. No SQL queries today.
Okay, good.
But you're right. Databases DO add a whole new level of complexity when it comes to backups. Remember when we talked about those ACID properties?
Right, ACID.
Yeah.
Atomicity, consistency, isolation, and durability. Those are important.
And they highlight exactly WHY. Consistent backups are so critical. You can't just copy the database files and call it a day.
Right.
We need to capture all those components in a state that preserves those ACID properties.
Okay, makes sense.
Otherwise, we risk ending up with a corrupted or unusable database when we try to restore it.
That would be bad. So let's jump into some examples. I'm particularly curious about Oracle databases. Those have always seemed kind of, mysterious to me.
Oracle is a big player in the database world, that's for sure. And they have their own set of lingo, their own processes. One key concept is table spaces.
Table spaces.
Think of them like containers for the data.
Okay, like folders on my computer.
Yeah, a good analogy. Each table space holds those physical data files, which are the files on disk where the actual data lives. And then there's the control file, which acts as a master index.
Like a blueprint.
Exactly. It keeps track of all those table spaces and data files. And of course, let's not forget those transaction logs.
Oh, those guys again.
In Oracle world, they're called redo logs.
The redo logs, got it.
They record every single change made to the database.
Okay.
So if we need to, we can roll back transactions or even restore the entire database to a specific point in time.
So they're like a detailed history of everything that's happened in the database.
Exactly. And these Oracle databases, they can get huge. So how do we back up something that massive?
Right. I was just thinking that.
Well, we have a couple of options. There are offline backups, sometimes called cold backups, where the database is shut down during the process.
Okay. So they guarantees consistency, but it also requires some downtime.
Right. And downtime can be expensive.
For sure.
So the alternative is online backups or hot backups, which can happen while the database is still up and running.
Much better for those business critical systems.
Exactly. However, this does require the database to be in archive log mode, meaning those redo logs are constantly being archived.
Okay, so it's a trade-off. We minimize downtime, but it requires a bit more configuration and planning.
Exactly. And when it comes to Oracle, we can't forget about RMAIN.
RMAIN.
The recovery manager. It's Oracle's built-in tool for backing up and restoring their databases.
Got it. So it can handle both online and offline backups.
It can. and even incremental backups, which focus on changes since the last full backup.
So it's like a multi-tool for Oracle backups.
That's a great way to put it.
But does RMN work well with, those other backup applications out there?
Most of them have agents that can talk to RMN and act as that intermediary to the backup server.
Okay, so we can manage Oracle backups seamlessly as part of our overall strategy.
Precisely.
Okay, so Oracle, I think I'm starting to get it. But what about other databases? Is Microsoft SQL Server similar?
There are similarities for sure, but also some key differences. SQL Server, it also uses data files and log files, but they have this concept called file groups, which are similar to table spaces. It's just another way to organize data.
Okay, so it's the same basic building blocks, just with different names.
You got it. And SQL Server also has different recovery models which affect how those transaction logs are handled.
Oh, right. So there's a simple recovery model, which is easy to manage.
Yes.
But then there's a full recovery model, which gives us those granular recovery options.
Exactly. And when we back up SQL Server databases, we have those familiar options: full backups, differential backups, and transaction log backups. And just like Oracle, most backup apps use agents to integrate and streamline the process.
Okay, I'm starting to feel better about these database backups in general. But what about applications that aren't traditional databases? Like, how do we back up something like Microsoft Exchange? That's email, right?
Ah, yes. Exchange. It's a unique beast. Instead of those table spaces and data files, we have information stores, storage groups, and mailboxes. Think of those information stores like containers for all those emails and attachments.
So like a giant filing cabinet.
Exactly. And they come in two flavors: private for individuals and public for shared data. And these stores, they're organized into storage groups which share transaction logs.
Oh no, not those transaction logs again. They're everywhere.
They are, and when it comes to Exchange, high availability is key. Microsoft has all these technologies for replication: LCR, CCR, and SCR. Haha, yes. But the point is, they all aim to keep those emails flowing even if a server crashes.
Redundancy, redundancy, redundancy. Got to keep those emails up.
Exactly. And for backups, Exchange supports those legacy streaming backups and those newer VSS-based backups.
Wait, VSS works for Exchange too?
It does. It's actually preferred, especially for clustered environments. And just like those other databases, we have full backups, copy backups, incremental backups, and differential backups,
Yeah.
each one with its own advantages.
I see. So it's starting to make sense how all this fits together. But what about SharePoint? Is that a whole different ballgame?
SharePoint is kind of a hybrid. It's not your traditional relational database, but it's built on top of SQL Server.
Okay, so it uses SQL Server underneath, but it still has its own quirks.
Exactly. It has its own configuration database for settings and content databases for, well, the content.
And those transaction logs are in there somewhere, I bet?
Of course, they're everywhere, remember.
Right, right. So we still need to think about consistent backups and recovery, even though it's built on SQL Server.
You got it. SharePoint has its own backup and recovery system, and we can use third-party tools for even more flexibility.
So each database, each platform, really has its own nuances when it comes to backups. It's a lot.
It is a lot. But once you understand those fundamental concepts, you're well on your way to protecting data no matter where it lives.
I'm definitely feeling more confident now. My brain is a little full, though. Are we ready to move on to the final part?
Absolutely. In the next part, we'll look at backing up and restoring data in those real-world client and remote office environments.
All right, welcome back. Feels like we've been on quite a journey with this Module 3.
It has been a deep dive, hasn't it?
We've explored everything from backup clients, file systems, databases, even touched on virtualization. But now I think it's time to bring it all home, you know?
Get practical.
Exactly. Let's talk about real-world client backups.
Sounds good to me. Let's get into it.
Okay, so let's start with those key things we need to think about when we're backing up data in a client environment. I mean, it can't be as simple as just installing an agent on every computer, right?
Yeah, definitely not. There's a lot more to it.
Okay,
For starters, we have to choose the right backup application.
okay. Makes sense.
One that supports the client's operating system, their applications, and can handle all that data they're throwing at it.
So, like, finding the right tool for the job. You wouldn't use a hammer to build a house.
Exactly. And then we need to think about our recovery time objectives, RTOs.
Right, those determine how quickly we need to be able to restore the data if something goes wrong.
Exactly. So we need to ask ourselves, do we need file-level recovery,
Okay.
or can we get away with restoring whole systems?
Because obviously, restoring a single file should be way faster than bringing an entire server back online.
Exactly. And we can't forget about the resources that are needed for those restores. Do we have enough bandwidth? Do we have the hardware, the software? It's one thing to have EV backups, but actually being able to USE them when you need them, that's a whole different story.
Right. So planning is key here. We can't just assume that restores will just magically happen.
Nope. We need a solid recovery plan. And, importantly, we have to test it regularly. It's like having a fire escape plan for your data. You hope you never need to use it, but you gotta know what to do if the alarm goes off.
I like that. Okay, so we've got our backup application. We've thought about those RTOs. What's next? How do we get organized?
It's all about how you group your clients and schedule those backups.
Okay, so maybe grouping those clients with similar data types together. Like all the accounting servers might have a different schedule than the marketing laptops.
That's the idea. And we want to schedule those backups during off-peak hours, minimize the impact on everyone's work. We don't want the backups slowing down the business.
Of course not. Makes sense. But what about those situations where you've got clients with tons of data? Like,
Yeah.
what if they have one of those giant video editing servers with, like, terabytes of footage?
Yeah.
How do you even begin to back that up efficiently?
Those large clients can definitely be challenging. We might need to look at some more advanced techniques.
Okay, like what?
Well, there's multi-streaming, where we send multiple backup jobs at the same time.
Oh, so we're splitting it up into smaller chunks, like parallel processing for backups.
That's a good way to think about it. And another option is to turn that client into a storage node itself. That way it can back up its own data locally and then replicate that to a central backup server.
So we're distributing the workload, taking some pressure off the network. It seems like there's always a solution. You think creatively.
There usually is. Now, on the other end of the spectrum, we have those pesky desktop and laptop clients.
Oh, I bet those are a headache.
They can be. They're not always connected to the network. Users might have personal data mixed with work files. And let's be honest, they tend to disappear just when you need them most.
So how do we tackle that?
Well, education is key. We got to teach users about those backup best practices,
Okay.
set clear data retention policies, and we might even want to look at a dedicated backup server just for these mobile devices. Trying to manage laptop backups on the same server that's handling those big database backups, it can be a recipe for a disaster.
Yeah, probably not a good mix. So we've got large clients, we've got those mobile clients, anything else we need to be ready for?
Don't forget about remote offices.
Oh, right. They're kind of like those noble clients, but on a larger scale.
Exactly. They amplify all those challenges we've been talking about. Bandwidth limitations, security concerns, disaster recovery, all of that gets more complex when you've got data spread out across different locations.
It's like everything we've learned, but supersized.
Exactly. We might need to deploy backup servers at those remote sites, use deduplication to save bandwidth, and of course, implement strong encryption to protect all that data traveling across the internet.
It sounds like a lot to manage, but those remote offices, they're just as important as our main data centers, right?
Absolutely. Data is data no matter where it lives. And speaking of data, we spent all this time talking about backups, but we can't forget about restoring it right.
That's the whole point of backups, isn't it?
Oh,
What good is it if we can't actually get that data back?
Exactly. And just like with backups, network performance is critical for restores, especially when we're dealing with large amounts of data or those remote offices. Bandwidth, latency, even those duplex mismatches can really slow things down.
Oh, those duplex mismatches. I thought we'd left those behind.
They always come back to haunt us. But seriously, network issues can really throw a wrench into things. We need to anticipate those problems, test our recovery procedures, and make sure we have the resources ready to go.
So it's all about planning, testing, and being prepared. It's not enough to have backups. We have to make sure they're actually going to work when we need them.
Exactly. That's what having a real data protection strategy is all about.
I think that just about wraps up our deep dive into Module 3. It's been quite the journey, and I'm feeling a lot more confident about tackling those real-world backup scenarios now.
I'm glad to hear it. And remember, data protection is an ongoing process. Technology never stands still, so we have to stay informed, adapt our strategies, and keep learning.
Well said. Thanks for joining us on this deep dive. And to all of you listening out there, keep those data protection skills sharp, and we'll see you next time for another exciting adventure in the world of data management.